So, greeting of the day. Myself, P. Udayakumar, Assistant Professor, Department of CSE, AI, and ML. So, today's topic which I have to present here is RCNN. The prerequisite to understand this concept is you have to be familiar with the CNN models. So, this is advanced version of CNN that is called RCNN. So, here the flow which I have to discuss today. That is what is RCNN, what is object detection, then RCNN architectures, the various steps, the processing steps of RCNN. Then we will see the RCNN families, the different evolutions from RCNN to faster RCNN. Then we will talk about the speed and accuracy of different RCNN models. Then finally we will conclude with summary and takeaway, then reference. So what is RCNN? It is a region-based convolutional neural network, especially used for detecting an object in an image. Okay, the application of this RCNN is the computer vision, especially it is a advanced model of CNN that is called region-based convolutional neural network. For example, what is object detection? The object detection is nothing but what we have three concepts. One is classification, localization, and detection. Classification is nothing but what is the object is, what is the object in that image. Then what about localization? The place where the image, the object is placed in the image. Then detection is nothing but both a combination of identifying and locating an object. This is called detections. Okay, this RCNN, for example, it is introduced in 2014 in the computer vision project works. So here in the RCNN, it will proposes above 2000 region proposal in RCNN models. So okay, the final classification, it have 20 classes. So let us see the architecture of this RCNN. So we have the various stages: stage 1, stage 2, stage 3, stage 4, and stage 5. In stage 1, we will give the input image for finding out, detecting an object in an image. So the stage 1, this input image. What about stage 2? It is here we using the algorithm that is called a selective search algorithm, which is especially used to detect an image, detect an object in an image, more than 20,000 regions. Okay, then after detecting an image, then we'll warp the image by using the size of 227 into 227 pixels. Then we further move to the stage 4. So here only the convolution process are happening. The convolution process is nothing but by applying the filter, and we will process an image. Then finally by pooling, we will reduce the size of the object image. Then finally we'll go for the classifiers. The classifier will classify what type of image it is, what type of object it is. Okay, the by through the bounding box regressor. So the finally this is stage 5. Okay, let us move to next one. There is a we'll see more detail about this selective search region proposals. Here the input is an original image. After image, it will have to go for the over segmentations. Over segmentation is nothing but the overall image. It will be split into different part of small set of images. Then it will pointing out with region proposals by square bracket, like that regions where more than 2000 regions. So how these regions are proposed? For example, by using the criteria like color similarities, texture similarities, and size similarities with along with the field compatibilities. So this all together work to find out the region of the objects. Here we will move to next step, step 2. That is after extracting the different objects from an image. So then we have to extract the feature from that image, the regions what we extracted. For example, the input is here the image, that is image means the different regions image. Then followed by we have to apply the convolution operations. Here we have three levels of convolution operations. Okay, then followed by the fully connected layers, especially for classification. That is we have two fully connected layers. Then finally we'll get 4096 feature vector size. So it will be used to detect to classify whether it is which object is belongs to, for example, car or tree or pen or pencil, something it will object. It will be finally will classify the objects. The next one, we have the SVM classification. that is bounding box regression. Here, after we are getting the from the fully connected neural networks, we will get the feature vectors. That feature vector is 4096 uh, features are there. From that feature vectors, we can able to classify the different objects. Here we have detect the car, we can able to detect the person. Here we can able to detect the dogs. Like that, we have 20 classes we can able to detect, classify. Then followed by that, classification is done by based upon the probability values. For example, here the input image we given in the car. That is, so it's the probability of maximum, it is a car, that is 0.97 percentage of probability. The person is 0.03, so it is not possible. So by using threshold value, we'll classify that it is a car. So by after detecting that object is a car, then we have to fix with the region of interest, that is called bounding box regression. So we will give the some square shape that it will point out this is the car, this is the person, or this is the um, tree or flower, like that. So by using this bounding box regression, using this xy coordinate along with the height. So by using these values, we can able to bound the box in the objects. Then we will see the different RCNN family, that are different evolutions. This RCNN, so that's a region-based convolution neural network. It have some problem with it. The computation process is very slow because of it have to detect, it have to select the objects, that is over 2000 regions. So it will take too much of time. So then they invented the fast RCNN. So for if you want to, after computation, if you give some image, the see the time delay between RCNN and fast RCNN. So the RCNN for inference, it will take 47 seconds to detect the image or objects. But what about a fast RCNN? It uses only 2.3 seconds to detect an object in an image. If you go for faster RCNN, it is it will detect an inference and an image by using 0.2 seconds. So which means faster RCNN given better performance when compared to the traditional RCNN. So these are different levels of evaluations of the RCNN, then followed by fast RCNN, then the faster RCNN. So this is a faster RCNN is the basic model, or for the nowadays we are using the YOLO model. The YOLO model is developed by using this faster RCNN. So for speed and accuracy, just see the comparison. I already told that. So the time taken to detect for a given image for the inference, it will RCNN, it will take 47 seconds. Faster RCNN 2.3 seconds. But what a fast RCNN 2.3 seconds. Faster RCNN 0.2 seconds. The accuracy 73 percentage here, 68 percentage here, 53 percentage. So what about the application of this RCNN? The applications are for autonomous driving. For example, the driverless car. Nowadays, the Tesla, we have the driverless cars. So in the driverless car, object detection is a very important computation process to detect an object while driving the car, moving the car from one place to another place. It have to detect the signals, it have to detect the pedestrians, it have to detect the road. For that purpose, we can use this RCNN. And also for medical imaging, for example, the MRI based image processing, especially in that we have the brain tumor is there. So we can able to locate the brain tumor within the MRI image through this RCNN. So these are all the various applications are there. Then surveillance also we will use for retail analytics. We are using this RCNN. And robotics. The robot have to move from one place to another place. It have to detect the nearby objects. So for that purpose also we are using this RCNN model. So finally we'll conclude with the summary and the key takeaways. So there is some many limitation in RCNN. So if we go, what is the solution for this limitation in the RCNN? Through the faster RCNN, we can able to get more uh, accuracy, and also the time delay. We can able to reduce the time delay. So by using the role polling, and also by it have the end-to-end training models, and it have this faster RCNN, that is called region proposal network. It will replace the selective search entirely from the RCNN. So then adaptive pooling is introduced in this faster RCNN. So, but we have RCNN, we have some limitations, like they have the fixed input size, it has the multi-stage pipelines, It have the large storage. It need large storage because if you give input image, that input image it will have to map with a different 2000 different images to detect any object in a particular image. So it will take too much time. That is means the larger storage it will need for computation. So faster RCNN it will give the better performance when compared to the traditional RCNN. So which means RCNN especially used for object detection, it achieved 53.3 MAP on the Pascal VOC in 2012. So these are all the reference which I used for these presentations. So for your feedback about my presentation, you can give the feedback by scanning this QR code. Thank you.